and welcome to another lesson on number systems. This lesson we're going to be converting between number systems. Specifically, we're trying to get from binary to hexadecimal, generally speaking, or octal to hexadecimal and vice versa. So let's get started. While the binary and decimal numbers are not very compatible, binary, octal, and hexadecimal numbers are very strongly related. So what that means is that decimal kind of lives in the human world. Binary, octal, and hexadecimal are kind of closely related, and they have similar number bases, at least when looking at it from a computer's point of view. And what I mean by this is, for example, you look at the powers of 2, you've got 1, 2, and 4. And if you look at octal, you've got 1 and it jumps directly to powers of 8. So it's almost like octal, one digit kind of does the work of 3 digits in binary. So you kind of have 1 digit in octal for every 3 digits of binary. In hexadecimal, we have 1 digit in hexadecimal for every 4 digits in binary, if you look at this the way that I'm looking at this. So there's some sort of relationship here between the grouping of the numbers in binary and the numbers in hex and octal. And we'll see that the number 4 for hexadecimal comes up a lot, and number 3 for octal comes up a lot. So you might not understand what I'm saying yet, but soon it'll start to make sense. So to convert between binary and octal, I'm going to tell you to make groups of 3. To convert between binary and hexadecimal, I'm going to tell you to make groups of 4. And then to convert between octal and hexadecimal, we're going to go through binary. And I'll make more sense of that as we go. But for now, let's just get into a basic example. So the first example here, octal to binary, which means we're going from base 8 to base 2. Okay? Now, in this case, we're converting from octal to binary, and that's easy if you memorize how to make the numbers 0 to 7. So in this case, we see the binary numbers on top and the octal numbers on bottom. So of course, no 1s, no 2s, and no 4s gives nothing. A 1 gives a 1 in octal. Remember, your place values for binary are 1s, 2s, 4s, and so on. A 2 in binary is 2 in octal. This is a 1 and a 2 in binary, which means you have a 3. There's 3 in octal. And same thing, you have a 1, how many 1s, 2s, and 4s you have? You have 1, 4, which is a 4 in octal, and so on. So these numbers in binary are directly mapped to these associated numbers in octal. So if you remember these, or you memorize these sets of digits, you'll be really well off. But for now, let's just get some practice. So the first exercise says to convert 631 in octal, that's important, to binary. And think about making groups of 3. This question's actually already done for us, but I'll break down what they did. They took the rightmost number and they broke it into its equivalent number in binary. Okay? 001 is 1 in binary. So they went from 1 and made it 001. For the next digit, they broke it down. They took the number 3 and made it into 011. That's because the number 3 in octal is 011 in binary. You see what I'm doing? And then they took the number 6 and they said, what's that number in binary? It's 110. And again, why is it 110? Because you have no 1s, you have a 2 and you have a 4. 4 and 2 is 6. So 110. Okay, and then you just write that out without the spaces, 110, 011, 001. That's the number in binary. That's the final answer. So if you followed what I did there, it's actually quite simple. You just take one number at a time and break it into groups of 3, which is why I said to convert from, between octal and binary, you make groups of 3. So that's what I was getting at when I said to make groups of 3. Let's look at another example. Example 2. In this question, we see it has a nice blank page for us, so we can kind of just do our work nice and cleanly. I'm going to write it out nice and big. The number 4,123, well, that's what it would be in decimal. It's absolutely not that number in octal. It's the number 4123. And just as a quick reminder, that's because we have 3 1s, we have 2 8s, we have 1 64, and then we have 4 or 5 12s. That's what this number means. So in any case, let's break it up into binary. This, make it into a group of 3, okay? Group of 3. What's the number 3 in binary? It's 0, 1, 1. It's in this table up top that I gave as a reference. Number 2, what's that? That's 0, 1, 0. The number 1 is 0, 0, 1. And the number 4 is 1, 0, 0. So I thought I was going to have tons of space for this. I actually didn't make it very pretty. But long story short, the number 4, 1, 2, 3 in octal is, let's read this number off, 1, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. That's our binary number. That's our final answer, which matches up here. If you're not sure where those numbers are coming from, let's be super clear. 0, 1, 1, 0, 1, 0, 0, 0, 1, 1, 0, 0. That's our number in binary. See how closely linked octal and binary are? That's because octal, you can represent a 3-digit binary number with a single octal digit. So it's pretty neat. It's kind of nice how these work together. And it's definitely not coincidence. It's just the way that these number bases work. So for practice, I'd like you to convert these numbers to binary. You can pause the video. I'm just going to write out what the final answer is. Okay, I'll pause it and just pop it up here. Okay, here it is. So these are the answers. I'd like you to try and get those on your own, pause the video and whatever else. But you can see that they're pretty big, especially for the second one. You got this massive answer, really. That's why it's useful to use octal or especially hexadecimal to represent them as smaller numbers. So the first one, I'll break it down, okay? You've got 634. 6 in binary, what is it? Well, actually, let's work from the right. So 4 in binary is 1, 0, 0. 3 in binary is 0, 1, 1. 6 in binary, well, it's a 2 and a 4, which means you have a 4, a 2, and no 1s. So if you group this together, we have our final answer. 1, 1, 0, 0, 1, 1, 1, 0, 0. That's our binary answer, which you should be able to compare above. 1, 1, 0, 0, 1, 1, 1, 0, 0. Nothing wrong there. The next one, same exact way. 3, 2, 1, 4, 5. And if you have a different way you want to write this out, you have a different style you want to try to break up the numbers, go ahead and do that. But I'm just breaking them up this way because I want it to be crystal clear for you. All right? Let's work from the right, maybe. A 5 is a 4 and a 1, so 1, 0, 1. 4 is 1, 4, no 2s, no 1s. 1 is no 4s, no 2s, and a 1. 2 is no 4s, a 2, and no 1s. And 3 is 0, a 2, and a 1. And we have this 0 in front. So I'll mention that in a second. But reading from right to left, it would be 1, 0, 1, 0, 0, 1, 1, 0, 0, 0, 1, 0, 1, 1, 0. But notice in our answer here, we don't have a 0. And that's okay. That's because normally we don't write down our leading zeros. So our final answer here is going to be this. So be careful with leading zeros. I'll just say leading zeros are not, we don't write them out usually, just like, the number 000000245 is really just the number 245. So why write all those zeros? They don't mean anything. Okay, and that's it for those 2 practice questions. So on the next page here, page 49, we're going binary to octal. So before we were going from octal to binary, now we're going binary to octal. But the thing to keep in mind is that because it's octal and binary, we're still dealing with groups of 3. All right, keep that in mind and you'll be fine. So the steps to go binary to octal are just the opposite of what the steps we did before. Break the binary number into groups of 3 digits, and then write the octal value of each group. So by break the number into groups of 3, really we're going to group. We're going to group it into all the digits into groups of 3. So convert it to octal. What it means is that from right to left, It says start from the right. So from right to left, let's do this. 1, 1, 1. That gives the number 7. 1, 1, 0. What's that? That's a 4, a 2, and no 1, so that's a 6. 0, 1, 0. That's the number 2. And 1, or 0, 0, 1, is just the number 1. And you just write them exactly as you see it. That's our final answer, 1, 2, 6, 7. And if you went backwards, you would be able to break it into binary and get the exact same number back. So really, really simple process. In fact, it's one of my favorite things to do in this course. And once students once it clicks, students really like it, believe it or not. So exercise 2 is this giant binary number. Let's try to tidy it up and make it an octal number. So the answer is here. So I recommend you pause the video here. Try to get that number yourself. It's a really good practice to be able to get that number yourself. But I'm going to work it out. I'm just going to work out from right to left, write all my numbers out. Okay, and use your table here as a reference, but you should really be memorizing these things. I can just write right underneath it, okay? 2, 6. Be careful you don't skip any numbers. This is a 1 and a 2, so 3, 0, 4, 4, 2. So let's read it from right to left. I mean, when I did this process, I went from right to left. That's to make sure that if I had any leading zeros in the beginning, which I do, technically, I can count for them. If you go left to right, you're going to mess up the number. What I mean by that is if you go from left to right on the beginning, look what happens. Right away, we get this 1, 0, 1. That's actually a 5, and that's not correct. So we write out the final number. I'll just write it more cleanly. 2, 4, 4, 0, 3, 6, 2. An octal. Okay, hopefully that's, a 5. Let's see, let's compare my work. I've got a 2 and I have a 1, 1, 0. That's a 4 and a 2. That's definitely a 6. So there's a mistake in the key here. It should be a 6 there. So in the next section, it's just practice problems. I'd like you to try them on your own. You can pause the video right now and try it. I'm going to put up the answers now. And here they are. These are our answers. If you have any issues with this or you disagree with them at all, just make a note of them, and that's exactly what that tutorial time is going to be. That's what it's going to be for on Wednesday, is to go through any questions you have. So next, we're going to do the exact same thing with hexadecimal. And the only difference is that hexadecimal has letters, so sometimes there's a little tiny extra step. But at the end of the day, most of it's almost exactly the same. So in exercise 1 here, oh, by the way, when we're converting from hex to binary, I mentioned this before, we should be using groups of 4-digit binary numbers, not groups of 3. Because if you have a 4-digit binary number with place values 1, 2, 4, and 8, the biggest number you can make, if you put 1, 1, 1, 1, is the number 15 in hexadecimal. So a set of 4 digits in binary is actually can be represented by 1 digit in hex, which is why we use our 4-digit convention here. So in exercise 1, convert A49 in hexadecimal to binary. A, the number A, is the number 10. And if you look in our table here, that's this, it's also 10. 10 is a 8 and a 2. Which is why we have how many 8s, 4s, 2s, and 1s we have? We have an 8 and a 2. That's why it gives us what it does. The 4 in binary is easy to make. No zeros, sorry, no 1s, no 2s. We have a 4 and no 8s. And so that's why it gives us what it is. What you see is what you get for that 4. It doesn't change to a letter. For 9, again in hexadecimal, the number 9, how do we make it? Well, it's an 8 and a 1. So we have a 1, we have no 2s, no 4s, we have an 8. An 8 and a 1 gives 9. And together, if we read that from the right to the left, we have 1, 0, here, I'll color code it for you. We have 1, 0, 0, 1, 0, 1, 0, 0, 1010. And so all we've done is we've taken each digit, exploded it into a binary number, which you can relate to the table. Just be careful to match it to the table. And then we get our final answer, which is obviously a big binary number, because for every digit in hex, we get approximately 4 binary numbers out of it. So it explodes pretty quick. Exercise 2. So we're really only going to do one more example, and then it's just practice for you. The number 5b01, convert this to binary. So we need to take our number 5b01, and we're going to break it into groups of 4. Groups of 4 digits. So 1, 2, 3, 4 digits, 1, 2, 3, 4 digits, 1, 2, 3, 4 digits, and 1, 2, 3, 4 digits. So I'll just start from the right. Again, just to be super crystal clear here. Is how many ones, if it's binary, how many 1s, 2s, 4s, and 8s we have? How many 1s, 2s, 4s, and 8s we have? How many 1s, 2s, 4s, and 8s we have? And how many 1s, 2s, 4s, and 8s we have? So just always keep that in mind when you're making your hexadecimal number. Number 1 in hexadecimal is the number 1 in binary. 0 is always going to be 0, whatever number system you have. B, let's look for B. B is the number 1011. If you can take from the table, you're not always going to have the table. That's because B in hex actually means 11, because 10 means 10 is A and 11 is B. And then that means you have an 8, a 2, and a 1. Add those together, 8 plus 2 plus 1 is 11. Hopefully that's review and not new to you. And then 5 is a 4 and a 1. You can write the 0 in front if you want, just to be complete, but when we write our complete answer, 5b01 in hexadecimal is, let's read it left to right, 101 1011 0000 0001. That's now a binary number. We don't write our leading 0. Okay? We don't write the number in front because it's not correct notation. And that's it. That's how we do hexadecimal to binary. So in the practice section coming up, it actually doesn't tell you how to get from binary to hexadecimal. So I'm going to go ahead and make one for you. I'm just going to go to the side here. I'm going to make one up for you. Okay, so now we've got this big old binary number, and we need to make it a hexadecimal number. So remember, the most important thing to remind yourself of is that we're going to do groups of 4 when we have hexadecimal. And we go from the right. From the right. Read it right to left. Okay? So if you read it right to left, you should be fine. Take a group of 4, right to left. What number is this? Well, it's an 8 and a 2, which is a 10. 10 in hexadecimal actually means A. Our next group of 4 from the right, okay, is a 0. We can keep that like it is. Our next group of 4 from the right is a 0011. That's a 2 and a 1 or a 3. And finally, 111, that is a 1, a 2, and a 4, which means we have the number 7. So at the end of the day here, our final answer is 730A in hexadecimal. I'd rewrite the initial number again next to it, but it's just a little bit of work, so no need. But this is how you go from binary to hexadecimal. So I've jumped ahead here to page 54, which is converting hexadecimal numbers to binary. So we'll get a little bit of practice with that. I'll put up the answers here, pause the video, and, well, let me put up the answers first. Okay, here they are, and I guess you don't really need to pause the video. You can do what you need, but this is the final answer once you convert from hexadecimal to binary. And again, I've done the exact same things before. I took each digit, broke it up into 4 pieces of binary, and then saw what the number was. So we're going to move on to one more topic today, which is octal to hexadecimal. So it says octal and hexadecimal are both closely related to binary. So the easiest way to convert between octal and hexadecimal is by way of binary numbers. So the steps here are convert to octal or hexadecimal number to binary, and then take that binary number and put it in the new system. So I'm going to make a little flowchart for you. just to make sense of things. If you have octal, you should then go to binary, and then you'll go to hexadecimal, and vice versa. If you have hexadecimal, you want to get to binary, go what I call go through binary. If you are doing octal to binary, you should be doing groups of 3. If you're going from binary to hex, vice versa, you should be doing groups of 4. And if you keep that in your mind, you should have very little trouble getting these questions done. So let's do our first exercise here. It's hexadecimal here to octal, which we're going to want to break this into binary first and then regroup it to make it octal. So let's see what we have. 8A9. Remember, binary first. Break it, it's hexadecimal, so groups of 4. 2, 3, 4. 1, 2, 3, 4. And remember their place values 1, 2, 4, and 8. So the number 9 is an 8 and a 1. A, just always remember that A is 10. You can hear my son out there. Which is 1, 8, and a 2. And then the number 8 is 1, 0, 0, 0. All right? Now that we have our hex representation, we can make it into octal. And how do we do that? Well, we need to make groups of 3 again. So let me just write out on the side here the steps that we've been taking, because some students would prefer to see it in steps. First, we're going to go from hex to binary. And that means we need to break it into groups of 4, okay? That's what we've done so far. We've finished that. The second step is we're going from binary to octal. Oops. To octal. And that's going to be making groups of 3. And in this case, we want to make groups of 3 from the right. So let's do that. I'll color code it. From the right, I need that number. I'm going to need this number. I'm going to need this number. I'm going to need this number. And many students find their own ways to represent this. I'm trying to make it as clear as I can to you. So in this case, the number 001 is 1. The number 101, that's a 4, no 2s, and a 1, that's a 5. The 010 is no 4s, a 2, and no 1s. And finally, 100, you should be getting better at this. This is a 4, a 2, and a 5, and a 1. So at the end of the day, the number 8A9 in hexadecimal is the number 4251 in octal. So we saw our 2-step process. Break it into groups of 4. So if this helps, this is our step 1. And then breaking it from binary and making it back into octal, that's our step 2. All right, it's more colorful than it is kind of mathematical or systematic, but I hope that you're making sense of this. I'm trying to give you the shortest possible way to get to this answer, and the simplest kind of way too. So exercise 2, I'd like you to take a look at this. Convert 7132 in octal to hexadecimal. And so take a moment, pause this video, see if you can get this answer E5A. Okay, so I've written down the steps that I'm going to take again, which I'll follow this time. It's almost the exact same problem as before, except for going to hex instead of from hex. So I'll write down these numbers, 7, 1, 3, 2. Remember, this is an octal number. I need to break each one into groups of 3. So I'll break that into a group of 3, break this, and break this. As a group of 3 from the right to the left, this is a 0, 1, 0. 3 is the number 0, 1, 1 in binary. You can read all these up top. You should really memorize them and know what they mean. This is 0, 0, 1, and 7 is, you should recognize this, a 4, a 2, and a 1. It's the biggest number we can make with 3 digits. Just like that. Now, I've done step 1. That's step 1. From octal to binary, I'm done it. I could read that number off in binary, that's what it would be. But I need to keep going. I need to go binary to hex. And so I'm going to group it in groups of 4. Once again, groups of 4. So from the right, This is our number. I'm gonna rewrite it. 1110010110110, just because I want it to be smaller. So groups of 4, that'll be this. I'll worry about that in a second. This is another group of 4. It's another group of 4. And we don't have any leading zeros here, so nothing to cancel off the front. And then we just convert them. 1010 means an 8, no 4s, and a 2. So 8 plus 2 is 10. 10 in hex is A. 0101, you can look at the table up top or just think about it. It's going to have to be 5. 1110 is an 8, a 4, and a 2, which is going to be 14. So I'll write the 14 first. 14 in hexadecimal is E. So at the end of the day, we have E5A, or 7132 in octal is equal to E5A in hexadecimal. So we had this little extra step of converting the letters. So convert the number to letters here if it's greater than or equal to 10. But that's the big idea. I still went from step 1 to step 2, still followed all the same steps as the previous example. There's just a tiny bit of extra work to do because of the way that hex works. All good? So there are some review videos. This guy is excellent. This is my favorite YouTuber, like I mentioned before, for this kind of thing. It's called Organic Chem Tutor. And sorry about my son, but this is the reality of COVID right now. This is a really good review of this stuff, and I think I might have stolen some of my examples from him. Okay, all we have left is a little practice sheet, and I'm going to put up the answers right now. And here they are. So you should absolutely be trying these questions yourself. Make a note of the ones that you have any issues with or you want to ask me, and then that's what we can do when we go through these questions on Wednesday. You just write down the page number, write down the practice, and I'll be happy to go through whichever you want. You can also contact me on Teams whenever you like. And that's it for today's lesson. So hopefully you learned something about converting numbers. The next lesson we're going to do will be, well, we're actually going to do a bit of a number game. And then we're going to start adding and subtracting. But let's worry about that another time. Have a great day.